students, welcome to your favorite channel Physics Philo. Apart from our regular teaching, today there is something new for you. Yesterday, when I attended Professor Panigrai's lecture on quantum computing, there is a seminar. It was really amazing. Therefore, I thought, why not my viewers will get an opportunity to listen to Professor Panigrai. And yesterday I requested, and today he has given permission to meet him in his home. Now we are sitting in his home. Uh, but today we'll discuss this new topic that yesterday's Professor Panigrai has given that interesting subject which was called quantum computing. So today I am here with Professor Panigrai. Professor Panigrai, he served as a faculty members in the National Institute of Technology, Rourkela, in the Department of Physics and Astronomy. He served there from last 23 years. He was working there, and now he has joined as head of the department at NIST Autonomous College, Berhampur. At first, I want to know actually regarding this quantum computing, because in the last year, from 2023, government has started an initiative of quantum mission, and it will continue up to 2031. So there is a buzzword around the students community, faculty community, and all the scientific community in India. What is this quantum computing? Sir, namaste sir.
Namaste.
Welcome to our channel Physics Video.
Thank you.
Sir, please explain to our viewers actually what is quantum and what is computing. Then we will discuss further.
Let me first tell you what is quantum and why you need a quantum. And counterpart of the quantum is our classical, and we are very comfortable with the classical mechanics for the macro world, for the macroscopic body or the bodies of sizable mass and size. But when you come to the micro world, subatomic level, electron, proton, neutron, meson or something like that, the classical mechanics ceases to work. There are enough experimental evidence which will tell you the failure of classical mechanics. That is why there was a quantum mechanics. Quantum mechanics is naturally a mechanics of probabilistic, though classically the deterministic, and the visualization, our mind is classically colored. So you can visualize it and you can measure it accurately, and you can also predict the trajectory of the particle accurately because they are the macro subject. But quantum mechanically, you measure it with a probabilistic nature, and so it is very difficult to visualize in classically colored mind the concept of the quantum mechanics. And quantum mechanics, it has its origin nearly 200 years. But now, because of the quantum mission, as my colleague had told, this field is highly alluring, and it is the right time to make the word quantum, and it will be applicable into the various fields. And one such potential field of application is quantum computation and quantum information.
Then, sir, I want to know regarding this quantum computation, how this quantum computing is different from the classical computing that we are using now in our mobile or our laptop or systems. So, kindly explain in a layman language how this quantum computing is different from classical computing.
Yeah. It's actually till the first generation ancestor computer to till today, all the computational work is done through the classical computer. Even our supercomputer, which you consider to be the high-speed computer, is also classical. Now there is classical in a sense, classical mechanics is classical computer, they are the unit or bit. So, and in quantum computation, it is qubit. So, bit may be 0 and 1. So, there are two, 0 and 1. So, all the problem in classical computer has to be developed through the bits. Now, either, there are contrasting character of the material, either spin up, spin down, yes, no, switch off, switch on, polarize, unpolarize, magnetize, unmagnetize, and also ground state, excited state. These are the contrasting features. If you say the ground state, switch off, unpolarize as 0, excited state, polarize, spin off as 1, there are two possibilities. Either it is 0 or it is 1. This is what you call the classical computer. So suppose EF2 has a computer of 2 bits, there are 4 options, either 0, 0 or 0, 1 or 1, 0 or 1, 1. So classical computer does the problem one after other. all the four steps, one step after the other. But in a quantum computation, there is a possibility of partly 0 and partly 1. So it is the superposition, say, that is what you call, say, all contrasting property may be partly the up and partly the possibility of both with different probability are accepted. So this is because of the quantum superposition, there is a parallelism. So all the four steps can be worked together. So classical computer take four steps, but all four steps combined together can be done at a time. So naturally, the process of the computer, the speed of the computer will be multifold increase if you take the example of 2 bit. If you take a 100 bit of quantum computation, it is equivalent to the present supercomputer. And if you have a vision of 500 qubit, it will supersede all the computation facility existing till now, the classical computation.
Sir, with a very simple example, I think yesterday you have given there like this telephone number or something. With this example, trying to explain how this processing of the classical computer happens.
Actually, what you say, suppose there is a database of 100 people and 100 phone number and they are randomly arranged. And you have to pick up what is the cell number of a particular person. And the database is quietly disorganized, it is random. So you have to make a classical search will take on an average of n, if it is a 100 database or n number of database, the classical search will take n minus, on an average, n minus 2 attempt. So on an average you require, sometimes it may be less than 50, sometimes it may be greater than 50, but on an average 50 attempt he has to do to find the particular cell number of a particular person. But if you make the application useful of quantum computation, which exists in the superposition state, in classically either it is 1 or it is 0. Sometimes what you say, either I am present. If I am present, my probability of the room is 100%. If I am absent, the probability of my presence in the room is 0. There is no other way. Either I am here or I am not here. If I am here, my probability is 100%. If I am not here, my probability is 0. There is no other way of other than these two. But quantum mechanically, you can say, partly there is some probability that I am here, there is some probability that I am outside the room, there is some probability that I am elsewhere. So it takes the superposition of all these states. So which leads to the massive parallelism. All the four steps will be carried out if it is 2 bit. If it is 3 bit, 8 steps. And if it is n bit, it is 2 to the power n. Suppose you take a quantum computation of 100 bit, it is of the 2 to the power 100 possibility are there. Okay. So generally for a quantum particle, you are giving some wave function. So if psi 1 is a wave function and psi 2 is a wave function, any linear combination is also a wave function. C1 psi 1, C2 psi 2, C3 psi 2. What is the probability that the wave function is psi 1? It is C1 mod square with different probability. So quantum computation is a probabilistic calculation. Though you will not get accurate, it will not only give you the solution, it will give you the probability of all possible solutions. Classical computer is giving the particular solution. It gives what are the other solutions available with relative merit.
Sir, yesterday also you have given an example. Just I want to explain simply to my viewers if I am wrong to this technique. Now suppose you have lost a key in a cupboard and there is suppose 100 number of rooms in this cupboard, okay, and every room has its own door. In the classically the way you tell, each door you have to open and search, each door you have to open and search. So it take much time to open 100 number of rooms inside this cupboard. But in quantum mechanics, quantum computing, what is developed, that means like 100 hands will enter at a time, and you will search and you will get the result.
It is not. It will not be drastically reduced to 1. There you have to take n 100 steps. Here you will take root over 100.
Okay, 10.
Root over n 10. Within 10 attempts you can find where is the key.
That means
suppose all, as he says, suppose all the keyboard are aligned. You have you don't know where you have kept your key. You did not. In a classical computation, you have to search all the cupboard. If you are lucky, you can get within 5 to 10. If you are not lucky, you will get also. You have to take an attempt of 90.
Yes,
but that doing the job of n by 2, that means 50, on an average 50 cells will be drastically reduced to 10 steps.
Okay. That means processing speed will
Processing
be faster
speed will be faster.
if you compare with the classical computer.
Classical.
Sir, what you told in the quantum computer, you want to get the deterministic result. Okay?
Yeah.
That means that is the probabilistic result.
Yeah.
But how I will find my accurate result from this series of probabilistic results?
If you suppose in one result is if you repeat the measurement, probabilistic will go to reality by repeating the experiment. If you repeat the experiment several times, then suppose the particular value is this, and most of the your repeated attempt, the probability of getting that result will be the highest. So from that, but it doesn't exclude the probability of not getting the result is zero. Just like in classically, if Professor Panigrahi is in this room, there is a probability zero that he is elsewhere.
Yes, sir.
But quantum mechanically, if I am here, probability may be 99% 999, but the probability that I am outside the room may not be treated as a zero, as classically you demand. It may be finite.
That means the maximum probability that we may assume that this is the
That will be the
solution.
reason. So that is the reason why what you say, quantum computation will make complex problems simpler,
Yes, sir.
but not simplest.
Yes, sir. Yes.
However, classical computers cannot handle it. No, this problem I cannot do.
Okay.
But whatever simple problem he will do, he will do it perfectly.
Okay, sir. Is okay.
So most of the time we are suppose before synthesis of a disease, before drug, you see, before doing anything, we must be understand there are various variant possible. Suppose you want to run a business, suppose you want to run a factory, suppose you design a drug. So various other possibility are also there. Failure is also there.
Yes, sir.
So when you invest such of money, you will think of what is the probability of success, what is the probability of failure,
Yes, sir.
what are the constant. So then you mentally, and sometimes you are also failure, but quantum mechanically he will tell you, if you go in this venture, this is the probability
Of success.
probability of success. So naturally you are going to compromise with that. So before experimenting, you can predict what are the success rate as well as the failure.
Okay. Sir, we have very short time. Within the 2 questions, we'll wrap up this interview session. There is a buzzword regarding the quantum entanglement.
Yeah.
So could you explain simply, briefly, what is
Quantum
this?
entanglement, you call it as a quantum twin.
Yes, sir.
You see, suppose you have two particles, they are entangled. You may ask question, which two particles will entangle? Say, a positron and electron. Because positron is the antiparticle of electron.
Yes, sir.
So they couple. One is if the electron, positron are particle and antiparticle. A large distance, Spocky action at the distance. So the property of one will influence the property of the other. They are in a mixed state. They are not in pure state.
Yes, sir.
And they don't have their own willpower. They have to, just like suppose twin brothers, wife and husband, if they are separated, also some of the property of the wife is influencing with some of the property of husband. Is something like that. Spocky action at the end.
That means
Similarly, twin brothers. Suppose a father has 4 sons, out of which 2 are twin, they are entangled. They are, if any one twin suffer with the cold, the other twin is also affected.
Yes, sir.
And they have additional bonding among other non-twin brothers. Twin brothers has some additional bonding.
Okay.
And in literary sense, you say as if they are entangled. As if they are entangled.
That means, for my viewers, it is like a unseen relationship
Unseen
between these
relation,
two
हाँ.
quantum states. So if you disturb one quantum state, automatically it will affect this another
Other
system
man,
which is
other
very
man.
far away from
Other.
from the different positions. Okay. Okay, sir. Actually, this channel is dedicated for the physics students.
Okay.
So, can you say anything? What are the scope of this physics fraternity in this quantum
You know,
revolution? What is happening now?
recently, the government of India has, actually we are very infant in this stage. But other developing country has a quantum leap and IBM, and they are also searching for, because there are searching for quantum algorithm and something like that. So, the reason is that, and also weather forecasting and chemical simulation, drug simulation, and if you attach with artificial intelligence also, looking to the data looking to the at present disease, suppose you suffered from a small, the doctor suspect cancer of some. And if you have a big data of similar disease leading to the cancer,
Yes, sir.
they can artificial intelligence
Extract.
through that, they can extract
Yes, sir.
and they can predict that there is a chances of being cancer after some time is 80% or 90 probabilistic.
Yes, sir. Yes, sir.
And also weather forecasting will be accurate,
Okay.
and computation speed will be enormously increased. Whereas a classical computer, which takes a month, year together, quantum computation will take within a second. And sometimes the problem which is not possible in classical computer
Yes, sir.
is also becomes possible. There is a possibility of people do not think of doing this because neither mentally nor computationally I can do it.
Yes,
You
sir.
can think of. That is why there is a quantum mission.
Yes,
And
sir.
quantum computation and quantum, and the another is communication will be secure. Now, suppose you want to give a communicator from one person to other person, there is no third man's intervention. The chances of data leakage is so communication will be secure. Security in communication. That is what is called the. So in every aspect of the life, it will influence our. That is why quantum is the supreme.
Yes, sir. But actually, what are my question? I'm repeating again. How does physics fraternity, as a student of physics, yeah, faculty of physics, what we can, in which way we can participate in this government's mission? What scope is there for us, the physics?
Yeah, prior to that, from first generation computer of our ancestor computer to till today, computation physicists are taking the help of the using the computer facility. But they are not involving the theory or what you say the hardware of the computational theory because nowhere physics is involved. But because of it is quantum computation, to go to understand much detail of the quantum computation, you have to understand quantum mechanics. So it is a high time. That is why a lot of online courses are being held on quantum computation, where physicists are involved to just make the idea clear what is the quantum physics to the quantum scientists. So it is the right time that both computer scientists as well as physicists will join hands to make it clear.
Okay. What Sir told that actually it has a wide applications in like quantum computation, then quantum biology, and then meteorology, that weather forecasting, etc. So it has a huge opportunity in future. And some countries, some leading countries also, I think, some world, they have already started the missions, and just last year India started this mission. And as I told that the physicist has a leading role in this mission. Earlier we are just taking this advantage of the computer for our research.
You are
but
taking
now it is a
exactly.
high time that physics people, they can directly take part in the development of this quantum computing. Also, sir, we can make this quantum materials which may help.
Which will house. You need a quantum
Yes,
mechanics.
yes.
It may be trap diode. It may be Josephson junction. It may be Cooper core. It may be magnetized solid, magnetized material, which has the magnetic moment up and magnetic moment down. If you apply a field, one magnetic moment will be aligned to the field. The counterpart will be, suppose there is a quantum entanglement of 2. If you apply in a magnetic field, then one of the twin will, if it is aligned in a positive x direction, the other twin will be aligned in negative x direction. So,
okay, thank you,
so
sir.
it will give a scope to material scientists also to give a space for holding qubit. Qubit has to be developed in a material domain.
Yes, sir. That means, in conclusion, we can say the physics students are the high time they can take the research career in quantum computations. I think in India there is a less of awareness regarding the quantum computing if you see these other countries. But the next 8 years, India is in the mission mode to materialize this quantum computers. Thank you, sir, for the nice talk. I hope my viewers they will get benefit from this effective talk.